I wanted to talk a little bit about NaN type and NaN for those who are either very familiar with data science, but perhaps not so much familiar with Python and some of the inner workings, or those that are just starting to learn Python for use in data science. So let's look at NaN type. So we'll set x equal to none, and we'll look at the type of x. And we see that the type of x is a class of NaN type, which is interesting. So there is an actual type called NaN type, and none is a NaN type. So how does none work exactly? Well, let's look at a very naive example. If x, print x is something, else print x is nothing. We see that x is nothing, is what's printed out from this statement. And the reason that is because none is falsy. So if we look at that statement, none equal to false. Oops. We see that no, none is not equal to false. And why is that? Well, because the type of false is bool. So none is different from false, but it is falsy. And it's falsy much like null is in other languages like JavaScript or nil in Ruby if you work in Ruby. So let's look at something else. Let's say we have a list of values, and we'll say for now they're all integers 1, 2, 3, 4, 5, and none. So our list is a list of integers with none. Now let's import a very popular library called Numpy, and we'll import it as NP. And let's try to use NumPy's sum function on our list. And we get this error, unsupported operand types for addition between integer and none type. So let's try that, 5 plus none. We get that error. You cannot add an integer and you cannot add a none type. In fact, you cannot add any numerical types with none. Now, if you've been working with data sets and libraries like Numpy or Pandas, then you're familiar with NaN, or not a number. So Numpy has this, NaN. Let's look at its type. It's a float. So NaN is a float, just like 5.2 is a float. However, if we try to add two floats, one of which being NP NaN, we get NaN. You try to add a number that is a number to not a number, you get not a number. So back to our list, A. We've got 1, 2, 3, 4, 5, and none. And we saw that when we tried to sum these with NumPy's sum function, we got an error because you cannot add an integer and none. So how can we fix this? Well, we could create a new list and use something called list comprehension. Now this is a pure Python example. So what we'll do is say 0 if our value is none. Otherwise, else the value itself for every value that's in our list A. And I hope I read that out well enough, but just in case, what this does is it says for every value in this list, if that value is none, return a 0. Otherwise, return the value itself for every value that's in A. And let's look at that new list. Whoop. Had a syntax error there. My screen break. This tells me to get up. I'm not going to get up. I'm going to skip the break. So let's look at our list. 1, 2, 3, 4, 5, 0. So what we did was replace none with 0. And this seems reasonable because anything added to 0 is itself, of course. So when we now use np sum on new A, we get 15. And that's what we'd expect. Now, like I showed before, NumPy cannot sum none, but if it sums NaN, it returns NaN. So let's look at a new list. 1.1, 5.2, 100.76, whatever, 0001, and NaN, which we know is a float as well. So we've now got this list with NaN in it. And if we try to use np_sum on this list as well, which now contains an actual NaN and not none, hopefully this isn't getting too confusing, Now that this list contains NaN and we sum it, we still get NaN. But there is a function in Numpy called NaNsum. So if you know that there is a possibility or a definite occurrence of a NaN value in your list or array, you can use NaNsum, and it's going to basically treat that NaN as a 0. So now that we've done that, what is another way? And you might arguably say a better way if you've worked with pandas. Let's import pandas as PD. So back to our original list with none in it. Pandas is smart. Let's convert our A into a series, and we'll call this variable that we're going to store this in series A. Series A is equal to panda series A. All right, let's look at that. Series A. Our none value, when converted along with the rest of the list to a series, is NaN now. And these are all floats. More interestingly, is we can use the sum function on our series from pandas, and it's going to do the equivalent of an NP NaNsum. So we've got our series A that definitely has a NaN in it, but let's say we also want to get rid of the NaN. We don't want the NaN. Many times you'll hear the expression drop NAs or drop nulls, drop NaNs when working with data pre-processing. So what we can do is say series A drop NA, and it's going to drop that NA. Now keep in mind, if you want to persist that change, obviously that does not mutate our original series. You're going to have to say series A equals series A drop NA. And there we go. So we've learned about none type. We've learned about NP NaN. We've learned about using Panda series to convert a list into a series that may contain a NaN and sum it just like we would if it didn't have a NaN, or if we use the NP NaNsum. I hope this has been helpful. I just wanted to give a little bit of basic information. Please feel free to leave comments or criticisms. I'm always looking to improve these types of videos and instruction. Feel free to like and subscribe if you feel so inclined. Thank you so much.